Oh, hi, this is my Lab 11, which is final home lab. So I chose making solar system based on giving data. So the problem is to predict date, month, and year based on the basic data. So main result was that I successfully predict those, but they are slightly off from the real value. Okay, so my initial conditions are from this planetary data, a website provide from T-square. So I use mean distance as you see, and from kilometer I converted to meters, everything. The orbital speed, yeah. And so those are my initial conditions. You see this red one? Those are the important ones. Those are the ones I use for the initial conditions. First of all, to calculate or to make a computational model, we have to know which principle is used. So I use gravitational principle, which is negative g times m1 times m2 divided by the distance between two square times the r hat, which is just the direction data. And I use momentum principle to update the position. So what you have to do is use p to predict the final velocity, and with the final velocity you will predict the position, and they use momentum principle. And there's one assumption I used to make a computational data, is that the only force acting on the planets are like sun's gravitational force, so other force will be negligible and will treat it as like zeros, so we don't really care about those. Okay, here's the initial conditions. As you see, there's a position data I used. There's a mass. There's a velocity I used just now. If you see the planetary data, just compare them, they will look the same. And momentum, just like initial velocity times mass. Okay, let's run this. Want to see in the big position, right? You see a lot of things, but let's zoom in and see this. The third one is Earth. The fourth one is Mars. Okay, the one in the middle is Sun. So as you see, it just rotates fast, and looks like Earth is the third fastest here. Let's turn it off, see what I got with the calculation. So year returns is out that is 366.05 days, and month was 30.5. The day is 24.1. The way I calculate this is you have the velocity, you have the distance it travels, so it takes time. It's just distance divided by velocity. That's how I calculate it. And month, I divide the year by 12. And let's see how close my data from the real data. So the year I got was 366 days, right? For the real data they gave us, not they gave us, but I found in the internet was 365.25. So it's a bit off by like a day. For month, the difference is like 2 hours. Yeah, around an hour. Yeah, for date, again, there is a difference, but you see that it's kind of close enough. Now, the reason why those data are different is from my assumption and my initial conditions. First of all, I said that the only force acting on the planets are gravitational force, right? However, maybe there is other planets will have a force on each other, so that might affect the rotational force, not rotational force, sorry, the orbital It's like how long it orbits. And second of all, it does not rotate in a circular motion. So it actually rotates in elliptical motion, but if you see my like computational data, it rotates in the circular motion, right? And from there, I believe that there will be an error between the real data and my computational model. Thank you for watching.